Hi there, and today we're going to have a look at some more equilibrium to see what happens when you change the concentration of a substance in the equilibrium mixture. Now, we said before that there was this thing called Le Chatelier's principle, and basically when you have an equilibrium set up, if you do something to it, the equilibrium mixture will change to counteract the change that you've put onto it. So we're going to have a look at what happens when you change the concentration. So firstly, let's look and see what happens when you increase the concentration. And when you increase the concentration, what you find is the equilibrium mixture will move away from this substance. It will start to produce more of the other things than the thing that you have changed or if you've increased. So if we can think of a kind of chemical reaction where you've got reactants and products, we could even write a wee equation. Do the equilibrium. If you add more reactants, then the equilibriums want to move towards the products to basically counteract the fact that you've added way more reactants. So it would move to the right over here. This minimises the reactant increase by turning it into product. So basically, it's the same kind of idea as when we're looking at pressure. You want to get rid of the extra stuff you've added, so it's going to change and move to the other side. And the opposite for increasing product. If we added more product, then that's going to want to move towards the reactant. Hopefully that makes sense. If you need to look back or pause or kind of read over, that's fine. Now let's have a look at what happens when you decrease the concentration, and obviously, as you can imagine, it's going to be the opposite. If the concentration is decreased, then the equilibrium will move towards the substance that you've taken away to replace it. So some products was removed, so I'll give you that equation again, reactants, products. If the product was removed, then the equilibrium is going to want to move to the right to replace it, keeping the equilibrium ratio. If the reactant is decreased, then it's going to move towards the reactant. Okay, so it's the opposite, it's going towards the left because it's the reactant you're taking away this time. So we're going to have a look at a kind of example here, and we're going to have a look at what happens when we change the position of equilibrium by changing concentrations of a cobalt chloride mixture. So what you get is if you put in some cobalt chloride and some concentrated hydrochloric acid, what actually happens is it sets up an equilibrium. You have the cobalt, which with 6 water molecules basically joined onto it, plus the 4 Cl- chloride ions, and that produces a cobalt chloride with 6 water molecules. Now, what happens is if I were to add to this mixture, when you set it up, it usually forms a kind of pink colour, which is why I've kind of underlined that. What actually happens, and you'll see this in a video that's coming on the next bit, it kind of sets up that kind of pinkish colour. However, when we add some more HCl, so HCl is going to give us chloride ions. That means that if we add more HCl and more chloride ions, which is going to be this, then that is going to move the equilibrium towards the right to basically get rid of that extra stuff you've added. That uses up the chloride ions, so what will happen is we'll have to end up having more products being produced. So that means that if it's going to move to the right, we've got more cobalt chloride, which is a blue colour, then we're going to see some blue solution formed. Now have a look in the video and you'll be able to see that happening, so there's proof to show that this actually does happen. The other thing is you'll see in the video that the person who's making the video then adds some water, and you'll be able to see that that actually makes the equilibrium go in the other direction, producing more cobalt with 6 waters on it, that pink colour. So it goes back to the pink colour, and that's because it wants to get rid of the water that you've just added. So you should be able to see that's 2 ways that we can see that concentration affects equilibrium. We can actually see it for our own eyes. So when you can see a colour change, that's ideal for these kind of things. Okay, so we're going to watch the video just now. So as you can see here, what's happening is they've got the cobalt chloride mixture that's kind of pink, and they're going to add some hydrochloric acid to that. So that increases the concentration of the chloride ions, and you can see now that that is actually turning blue. So they're forming the cobalt chloride rather than the cobalt with the water. Then what they're going to do is they're going to add some water, and you should be able to see that turning back to that nice pink colour, because you're increasing the concentration of water, you're increasing water in that equilibrium mixture to make it go back the way. So this is moving and changing those colours because of Le Chatelier's principle, which states that when you add something to the chemical reaction, the equilibrium, then the equilibrium mixture is going to change to counteract that. So if you add more chloride, it's going to become blue, and if you add more water, it's going to become pink. Okay, so we have an equilibrium mixture here, which is ethanoic acid with water produces this CH3COO. That's the ethanoate ion. So that's when your ethanoic acid loses one hydrogen, and then plus the hydrogen ion. Okay, so what we need to do is we need to decide what's going to happen to the equilibrium position if we add some sodium hydroxide, and we have to think about this quite carefully. So if you actually write sodium hydroxide like this, that doesn't actually tell you much. When these have ions on them, so you've got the minus here and then the pluses, I would make sure that I show any ions that I've got in anything that I'm adding. So actually, if we write sodium hydroxide, it's NaOH minus. And actually, what's going to happen here, don't worry if you can't see this straight away, I'm going to do a wee kind of reminder a few slides. But what's actually going to happen is the OH minus ion, the hydroxide ion, if you can remember back to National 5, if that comes into contact with any H+, it actually does a neutralisation reaction. So that actually comes out to form water, H2O. That means that if I added in some sodium hydroxide, then that hydrogen is going to be neutralised, and therefore it's going to be taken away out of that mixture, which means that the equilibrium mixture is going to go to the right, towards the products. So I can actually write that in a kind of sentence to make that easier to understand, but when sodium hydroxide is added, there you go. So when sodium hydroxide is added, the OH minus ions neutralise the H+. This removes them from the equilibrium, and the equilibrium then produces more reactants to replace the lost H+. That is what's happening here. So if that's not making sense, here are a few reminders that might help you. From National 5, you should remember that when hydrogen and hydroxide go together, they make H2O. In the reaction at equilibrium, if an acid and alkali is added, this will have the effect of reducing either the H+ ion or the OH minus ion concentration. Because of the neutralisation, those are taken out of the equilibrium. They are used up, they form water, and water isn't part of your equilibrium that's set up. Then you need to replace them, and the equilibrium will move to replace them. Another thing we need to be aware of is something called a precipitation reaction. And basically from National 5, you should remember that a precipitation reaction is when you have two solutions which form a solid. If there's a change of state that forms a solid that comes out, and it's a totally different thing. So if you had something that reacts with one of the ions that you're adding in, then that's forming a new substance that's not in your equilibrium. So therefore, that actually takes away some of the ions that are in the equilibrium, and that reduces that concentration. So the equilibrium will change to allow that to be replaced. So watch out for adding silver solutions to equilibrium, as these generally make precipitates. Usually all of the silver things that are added usually form a precipitate because they're insoluble. If you are stuck and you can't remember where to find this, to find out if they're insoluble or not, then you take out your data booklet and you need to turn to page 21. Okay, so that's going to be helpful for you here. You want to go to page 21 of your data booklet to make sure that you can see if things are going to be insoluble. Okay, and if we have a look at this one, this is just a wee example to see how equilibrium position could be changed if silver nitrate was added. Well, I told you in the previous slide that if you add in something that's got silver ions, then usually that is going to basically form a precipitate with something usually. So if I look and I see the things that it could form a precipitate with, remember silver is plus. So it's going to form something, a precipitate with something that would be negative. So if you go to your data booklet, you go to page 21, you would actually see that silver chloride is insoluble. That means that it would form a precipitate. So if that is going to come out, that's going to form a precipitate. Then that means that what's going to happen is you're going to have the equilibrium position move to replace those lost chloride ions. So what's going to happen is there's neither silver positive or nitrate negative ions present in the reaction. The silver ions will form precipitate with chloride. This combination are insoluble. So what's going to happen is the concentration of Cl is decreasing, so the equilibrium will move towards the right to replace it, just that. Okay, so hopefully that makes sense. Decreasing concentration, it can be decreased in three ways. Actually removing the reactant or product. If you have neutralization by adding H plus or OH minus, or adding an alkali and acid if you've got H plus and OH minus in the reaction, and also the ions form a precipitate. So that's a nice wee summary slide for you. So here's a wee example for you, and I'm just going to put the questions up just so you can have a look, and then I'm going to actually answer them for you. So you may want to pause here, do the questions, and then listen to the answers, and you can kind of think through them. Okay, so let's start with chlorine gas. Okay. If you add chlorine gas, what's going to happen is it's actually going to move the equilibrium towards the right, because you're going to be using up the more chlorine gas that you're adding in. Okay, add Cl2, G. This will move equilibrium to the right. And that is because this will remove there you go. If you add sodium chloride, what you're actually going to do is you're going to increase the chloride ion concentration. That means that it's going to move towards the left to take away those extra chloride ions. That should be left. So this will move equilibrium to the left to remove extra Cl. If you add lithium hydroxide, it's going to do the same thing. It's going to move to the left because it is going to react and neutralise with the H+. So what that will do is that will move it to the right to replace neutralised H+. And if we remove perchlorate ions, that would actually move it to the to the right to replace the removed perchlorate ions. Okay, so that's going to move to the right to replace the removed perchlorate ions. Okay. So last wee one for you. We've already actually talked about this one, but what would happen to the position of equilibrium if sodium hydroxide was added? This is removed, so removes H+, so equilibrium moves to the right to replace H+. See, there you go. So hopefully that makes sense. I think the main thing here is looking out for, if you're going to make a precipitate, are you going to do a neutralisation reaction, and are you going to be removing anything? And I think just having a think about what you're adding and removing, and then the equilibrium does the opposite, I think should make sense. But if you need a hand, then you can let your teacher know. Hopefully this does make sense though, and there's some questions for you to do in the attached worksheet.